Good evening, everyone. Welcome to the session number 4 from the chapter of atoms. The topic is Bohr's model, and based on this topic, I have written here 3 important points in order to understand the Bohr's model in brief. So, Bohr added the following postulates to the Rutherford model, and these are the 3 important postulates which were added by Bohr to the Rutherford model. The first point here is that the electrons revolve around the nucleus in fixed orbits, and the angular momentum of the electron is given by this formula, that is this angular momentum, which is denoted by capital L. This is equal to m into Vn into Rn. This is equal to nh upon 2 pi, where n is a positive integer, and here Vn is the velocity of the electron in the nth orbit, Rn is the radius of the nth orbit, and m is the mass of electron. The second important point is that electrons do not radiate energy while they are revolving in fixed orbits. They radiate the energy when the electron jumps from a higher orbit, or you can say from the outer orbit to the inner orbit, and it absorbs the energy when it jumps from the inner orbit to the outer orbit. Now the third important point is the Bohr's frequency equation, which is given by En minus Em is equal to Hf. Now let us consider that an electron is jumping from the nth orbit to the mth orbit. Now here nth orbit is the outer orbit and mth orbit is the inner orbit. So if the electron is jumping from the nth orbit to the mth orbit, then the frequency of the radiation emitted will be given by this equation. That is the energy of the electron in the nth orbit minus the energy of the electron in the mth orbit. This is equal to h into f, where f is the frequency of radiation and h is the Planck's constant. So in the next session, that is in the session number, or you can say in the coming 3 or 4 sessions, I will be now taking a few simple questions which will be based on the Bohr's model. So till then, have a nice day. Bye.